Hello everyone. Welcome back to another episode in our series on deep testing, automated tests beyond the basics. I'm Alex and I'm here with KIaus, David, and Lucas. And today's episode is going to be very interesting. I think one of the, I guess to me, more esoteric themes because these are techniques that I myself haven't applied very much. So we're going to be talking a little bit about generative testing, property based checking, and mutation tests, which I think are very, very interesting topics. But to start, maybe we'll introduce our guests. So Lucas, can you tell us a little bit about yourself?
Atualmente trabalho num projeto de desenvolvimento e sustentação de aplicação mobile. Estou há mais de 10 anos aí na área sofrendo aí. e estou bastante ansioso para esse nosso bate-papo aí. Acho que o assunto é bem interessante e vai render bastante.
Welcome. And David, welcome. Can you introduce yourself?
Well, hello. I'm David. I am being recorded from North America in Chicago. So what can I tell you? I work with Nubank now. I work with Cognitect, and we were acquired by Nubank last year, which for me is great because I have an extended family in Brazil already, and now I work in Brazil as well. Although we only started working in Brazil after the pandemic started, so I've only worked virtually in Brazil. But my time will come. So I've been working in software since about '99. In the early 2000s, I got really interested in the whole extreme programming and like the early days of Agile and test-driven development. I worked on an open source testing library in the Ruby programming language, which is called RSpec. And testing is something I've been thinking about for a long time. I used to be very, very rigid about doing test-driven development, and I've since working with Clojure over the years, where a lot of the feedback that we get from the TDD cycle, we can get that same feedback from just interactive development in a REPL. And so I always, ship code with tests, but I can't say that I'm really following a TDD process anymore. And I can't really say what the process is because I haven't articulated it even to myself. But anyway, we're here to talk about generative testing, or at least I am. And so that's something that I've explored quite a bit, and we'll talk about it.
Awesome. Welcome, David. And I'd like to say thank you because I wrote a lot of RSpec tests back in the day, and I got to know you through the book, and it's so awesome to have you as a colleague today. To mention TDD though, I just want to maybe go on a tangent here and say you've earned the right to transcend the practice because you actually tried it, right? I see a lot of people that never really tried the quick feedback cycle from TDD. I was like, this doesn't work, and then they want to try something else. But very interesting. But maybe for another episode, we could talk about transcending TDD and REPL-driven development and all that. Today, going back to generative testing, I went back on my notes, folks, and I was like, when did I first hear about this? And it turns out it was in 2008, so 13 years ago. In the first time I heard about like generating data, generating examples to test your app, it was actually through this little experimentation software that was called Tarantula. And Tarantula was a Ruby framework that crawled your Ruby on Rails application or whatever. You could test any website, and it would inject data. Like, for example, if we would find an input, it would inject, semicolon, drop table, post, semicolon. And I was like, oh my God, this is so cool. So I have this thing that just generates data that will break my app. Definitely inputs that most people won't think through. But I found it generally cool, right? In terms of like, oh yeah, it's some exploratory testing, and it helps me find some bugs or some security flaws that I didn't consider. And I think that it was a very focused, kind of limited application of what came to be, as we know today, this concept of generative testing. And in my own experience, and I'd love to hear about everybody else's, when you first got to hear about this type of technique and how you applied it. I have not applied, at Nubank, I think David will talk a little bit about later. We have a complete contract testing framework that depends on generating a lot of these namespaces, but before this experience, I didn't have many chances to say, oh yeah, I'm going to use the computer to come up with data and examples to find problems in my code. But I do remember the funnest time, and I'm sure there were a couple more, but this is one that came to memory. About 5 years ago, I was working with a company helping set up a continuous deployment pipeline for them. And one of the things that we need to do was a Microsoft .NET Core type shop was to generate these version names, right, for the the installers, the DLLs, and they had to be incremental and unique. And at the time we were experimenting with F#, and F# had some really cool generative testing libraries, and we wrote a test that just came up. One of the things that we used as an input for this version number was a date, right? So it came up with a bunch of things, including dates, and then checked a few properties, like this thing has to be unique, right? So you can't have flashing things. And I just remember the excitement of the test breaking and us finding there was one of those turn of the year kind of leap year kind of bugs, and it's like, oh my God, I've been bitten by these so many times, and I've never been able to write a test that finds them. And here, after just running a couple seconds and coming up with the crazy example that I forgot, the computer was able to find this bug in our code, and it was just so satisfying. How did it come about for you all? When did you first kind of hear about this concept and any stories of applying it?
Então, eu vou aproveitar e perguntar para o Lucas, para quem está assistindo aqui agora e não percebeu ainda, esse episódio vai ser metade em inglês, metade em português, vai ser híbrido, né? Então eu quero perguntar para o Lucas, né? Com o David a gente vai falar do conceito de generative tests, né? Testes generativos, e com o Lucas, testes de mutantes, né? Que é um pouco diferente. Eu ouvi falar de testes de mutantes em 2002, sempre quis usar, eu acho animal o conceito, mas nunca cheguei num projeto que tivesse num grau tão bom de testes que precisasse usar análise de mutantes. Então, Lucas, aí, respondendo, né, queria que você respondesse aí a pergunta do Freire, quando é que você começou a ouvir falar dessa história de mutantes, como é que você aplicou, se é que chegou já a aplicar em algum projeto real aí?
Já aplicamos, né, num projeto real esse teste. Só voltando um pouquinho antes para introduzir, né, a questão do porquê que a gente aplica, né, os testes de mutação, né. Então, quando a gente aplica testes automatizados de maneira geral, a gente está sempre pensando em obter ali a confiança em relação ao código que a gente está aplicando, o código que vai subir em produção, a segurança para refatorar o nosso código, antecipar falhas, né. Porém, é bem comum, como que a gente verifica se os nossos testes realmente estão sendo aplicados de maneira eficaz, né? E é bem comum um cenário onde times utilizam apenas como parâmetro para medir a qualidade dos seus testes a cobertura de testes tradicional. E a cobertura de testes tradicional ela não garante que os meus testes estão sendo escritos com qualidade. Ele só garante que o meu teste está executando o trecho do meu código, né? Só eu passei por aqui, mas não garante os mais diversos cenários, né? E que a gente tem, tanto em relação a input coverage ou cenários diferentes dentro do meu sistema, né?
Tem muito teste, né, que passa por milhares de linhas de código e tem um assert só no fim, né? Então,
exatamente. Então, às vezes, um time, é bem comum lá, o time estabelece um quality gate, então vamos fazer, meu código não pode baixar de 95% o nível de cobertura, né? Mas continua bombando bug em produção, né? Então, o que está acontecendo aqui, né? Tem alguma coisa de errado, né? E o interessante, tanto dos testes generativos quanto dos mutativos, é porque eles vêm para corrigir um gap que nós desenvolvedores temos, que é de tender a testar o caminho feliz das coisas, né? Então, a gente não consegue imaginar os mais diversos cenários, mais diversos inputs e dentro dos nossos testes.
A gente não consegue imaginar as coisas que a gente não imaginou, né?
Exatamente. Exatamente. Mas às vezes que eu apliquei os testes de mutação no projeto foram em pontos específicos, porque em uma das desvantagens que ele tem é o alto tempo de execução, né? Então, geralmente a gente escolhe alguma área do nosso sistema onde é um pouco mais crítica e a gente acaba de forma gradativa aplicando primeiro nessas áreas e depois crescendo um pouco mais, porque ele tem um alto custo de processamento. E nos projetos que a gente aplicou, a gente começou aplicando dessa maneira.
Você quer falar um exemplo, dar um exemplo, ou falar do conceito? Ou vamos voltar para o David, já pedir o conceito do... What are generative tests? Freire, do you have a more specific question?
Well, so I heard... I understand some Portuguese, but I didn't understand all of it, but I heard... the idea of coming up with new kinds of scenarios that you wouldn't come up with, and the mutation test helps with that. And generative tests do a similar kind of thing. The idea is that instead of writing examples where you handcraft your inputs, you generate them and you describe a range of valid values for inputs, and then you let your generator randomly select from within that range some number of inputs and run a test over and over again over a function, or we'll go just with that. And then you assert some property of the output. Actually, I'm talking about a specific type of generative testing right now, which is property-based testing. At a more base level, just the idea is generating the inputs. So, Freire, when you were talking about the date thing, I've seen a lot of, I've actually seen that where on January 2nd or whatever the first day back to work was, they were failing tests. Because somebody hard-coded some date and then the turn of the year. And actually, I think the code was fine. It's just the test was bad because of the way it was written, but I can't remember. But it got attention is the point.
David, the properties you mentioned, are they like invariants?
Sure.
Okay.
So, well, but it could also be a more general property. Like, so when we talk about mathematical functions, you could say, and I'm going to show an example of this later, but like addition is commutative. It has property. And so you can assert that in a test.
Interesting.
For all inputs that are shaped like this or have this quality, all the outputs should have this quality, this other quality. That's for the property test. But even before you get there, just generating the value can expose things instead of handcrafting examples. There are other benefits too. lot of times we're dealing with data structures, and I've seen a lot of tests where the input is this giant data structure, and then the output is this giant data structure. And really, the thing we're testing is one field. But in order to understand the test, you have to look at this giant data structure, and it's just a lot of noise. And when you're looking at a lot of these examples, it can be a real challenge. And so if you could generate from some specification, this is what the data structure is supposed to look like, and then you say, I'm going to generate this randomly, and specifically I'm going to set this particular field to this value, and then I'm going to check the outcome based on that at the end of this test. The test shrinks from like this down to this, which is, it sounds, I don't know what it sounds like. It may not sound that exciting, but it's really exciting.
It sounds exciting. Let's go.
The other nice thing about that is as the software evolves and the specification for the input values changes, unless the change impacts what you're testing, that one field that you set the value on, you probably won't have to touch that test. And I know that we've all been through this thing where we change data structures and we have to go change 50 tests that have nothing to do with what we're changing or new capability that we're adding, just because we're dealing with a whole bunch of hard-coded data.
And is that how you came about this practice, David? Were you tired of like keeping fixtures up to date, cutting and pasting the same JSON over and over so you could call an API? Do you remember kind of when this caught your eye and how
I don't remember like my generative origin story. It's something that I had heard about. We didn't really have a good answer for it in the Ruby world. When I started working with Clojure, there was Clojure Test Check, which is a library that is freely available for everybody to use, and it's an implementation of a library called Quick Check that comes from Haskell, but it's the same idea where you can. It's a sort of like a framework for running these generative tests, and then I'll show you later when we get into showing some stuff how helpful it is. But no, I don't remember like the moment, the light bulb.
The radioactive spider that bit you.
Well,
if you don't remember, David, it's possible that you're a villain and not a hero in the generative testing world.
I can accept.
Don't you think you could be?
I can accept it. As long as people learn from my terrible example.
And David, have you gotten a lot of mileage out of it? It's like, do you use it in every project? How's your experience applying this testing technique? Or is there like an intuition or a rule of thumb is like, oh, for whenever I'm working with dates, I make sure to cover or something like that?
Well, I mean, I have a bias towards generating as much as possible. And, you know, there's a place for examples, right? So sort of, you could think of, there's on one side of the wall, there's example-based testing where you hard code the example and you say things about like famous values and this sort of thing. And on the other side is generative. And I think, so when I use generative testing, I don't use it exclusively. I mean, there are cases where I do because it works out fine, but I don't have any kind of guideline about that. Like, don't use examples when you could use generative tests, because examples are examples. They tell a story. But if I could have 3 examples and 1 generative test instead of 50 examples that don't fully cover the input space, I'm much happier.
The way you described it, David, reminded me of fit tests. You know, fitness, the table-based thing.
Yeah.
Based on tables.
So
it sounds like a next step, a natural next step from fitness. You know, if I have the values here as a table, why don't I just generate the next values, because I've already eliminated like the fixtures, the boilerplate, the huge data structure you described. You sort of eliminate that in fit already, and you just have the actual important changes, right? So if you have that already, why not take the next step and generate the value?
I agree, although I think these tools serve different purposes. The value proposition of fit was part of the value proposition, I should say, was that because of the fact that it was presented in a tabular format and you could show it on like a wiki page, it was an entryway for non-technical people to be able to do exploratory testing. So they could go in and say, well, what happens if I throw 37 at this function? Without having to engage a developer to try that test. But just the idea of having an example that's clear in front of you and being able to explore with different inputs and then taking the next step from that and generating them, that makes a lot of sense.
Okay, maybe we can ask Lucas about the concepts of mutation tests, and then we can start seeing some code examples and examples in general.
Sorry, just before you go, because I wanted you to tell us a little bit also if there is an origin story, or if it's like how much mileage you're getting, right? I use it every day. It's like you mentioned that they take longer to run. So and maybe help me out, because my understanding around mutation testing is that it's more about testing your tests. I mean, at least I've seen, and what I've used is I have my test, I mutate the code. If the test doesn't break, but I know the code is broken, I know I'm missing some coverage there, right? When I ran into this, it was around the same time frame, 2005, 2008,
Freire,
something like that.
Freire, that's it. You explained it all. We can go home now.
But I was reading this paper from the University of New Mexico, and they were talking about actually repairing bugs with mutation. So it was a generic algorithm to mutate your code to pass a test that
very nice
question, right?
Okay.
And this particular story is like when I was like, okay, this is gold, there's something here. There was some C code that generated an infinite loop. And when the input was the last day of a leap year, again, leap years and dates. And this was on the Zune MP3 player by Microsoft. They shipped 1.2 million units with this bug. It generated 30,000 types of complaints, and they're like, oh, drain the battery and reset your player, and then everything's gonna be fine. And this algorithm, by changing the code and trying to pass the test, found and solved the bug in 42 seconds. And I was like, wow. And this is millions, like recall and like the PR for Microsoft and stuff. But I've actually, beyond using it to find problems with tests, haven't used it to fix the bugs or anything like that. How's your experience there, Lucas? And how often do you use it? When did you start?
Bom, basicamente é bem isso que você mencionou, né? O conceito é de que eles são os testes dos meus testes, né? Os testes dos seus testes. Ele vai avaliar a qualidade dos seus testes. O conceito, basicamente, é o seguinte: falhas ou mutações são introduzidas no seu código, né? E a partir desse código, em cima desse código são rodados os testes, né? Se o teste falhar, beleza, você tem um mutante morto. Só para alinhar as terminologias, né? Quando a gente tem a mutação, que seria modificações, pode ser modificações em operações lógicas, em condicionais, strings, declarações de arrays e
Dá um
etc.
exemplo, Lucas, por favor. Como seria?
Seria um exemplo, por exemplo, vamos supor que você tenha eu vou até mostrar mais para frente ali na prática, mas onde você tem uma versão do teu código lá que uma parte da lógica está verificando a força da sua senha, basicamente, ou no número mínimo de caracteres, né, da sua senha. E essa condição ele pode mudar esse operador lógico para contabilizar o número de caracteres que você quer para sua senha, mínimo para sua senha. Ele pode alternar de maior igual para menor igual. Então ele vai modificando o seu código, vai colocando mutações do seu código com o intuito de como se estivesse forçando erros mesmo no seu código.
Então tipo, troca um maior igual para um menor igual, bota um not, uma condição lógica.
Um true por false.
Por false, de um igual para um diferente.
Exatamente, são várias condições. E assim, é como se você tem o seu código principal e você tem versões do seu código com essas mutações. Cada versão desse código é chamada de mutante, né? Então os seus testes vão rodar em cada um desses mutantes. E se o seu teste passar em um desses mutantes, você tem um mutante vivo. Aí temos um problema. Como assim? Eu modifiquei seu código para uma versão e continuou passando a seu teste, né? Que nem o Alex havia comentado ali, né? Então, tem algum cenário que tem esse cenário que dessa versão do código que foi gerado não foi contemplado dentro dos seus testes. Você não tá confiante, com um nível de confiança em relação ao seu código real que vai para produção, né? Então, é uma ideia.
Desculpa, como que você garante que a mutação não melhorou o seu código? Talvez passou o teste porque o código ficou melhor.
Pois é, nunca tinha pensado por esse ponto, né? Pode ser que tenha ficado melhor, né?
Acontece o contrário, né? Como você falou, testes estavam falhando, passam agora, né?
Exatamente, né? Se agora passou, melhor ainda, é mais um acerto que eu tenho ali garantido no meu teste. Mas é uma ideia que funciona, ela é uma ideia meio maluca, mas que funciona, né? Geralmente as pessoas falam, que eu mostrando que versões modificadas do meu código não é uma forma de eu tirar a prova real da minha versão real da minha versão principal do código, né? Então, essas versões, esses mutantes, eu matando esses mutantes, acabando com esses mutantes, eu estou aumentando o grau de confiança de que o meu código é o certo para ser aplicado, para subir para produção, né? Então, e a partir disso a gente consegue medir a qualidade dos nossos testes a partir do nível de porcentagem de mutantes mortos, né? Eles usam essa terminologia mesmo, killed or survived. Então, é bem isso. Nosso objetivo acaba sendo derrotar esses mutantes dentro do nosso código.